These are old printers, computers, and phones, and this machine's shredding them to be recycled. Only about 17% of all electronic waste ends up like this.
It's very hard to recycle electronics. They're not designed to be recycled.
There are hundreds of tiny pieces hidden in every device, from toxic materials to plastic to gold. And they each have to be separated and recycled individually. Such precision takes lots of people, space, and heavy-duty machines, with a good deal of feminine power.
Sally is our big shredder. Heidi is German. Ginger's our metal finder.
Female-dominant machines.
Of course, yes.
And if everything goes right, there's lots of money to be made.
We'll pull off the pieces which will be of value.
That's Ingrid, president of Sims Lifecycle Services, one of the largest e-recyclers in the US. Ingrid took us through her biggest facility to see how it's repurposing or recycling up to 6 million pounds of old electronics every month.
So we're in Laverne, Tennessee, just outside of Nashville. This is a 200,000 square foot facility where we focus on receiving, processing electronics.
Sims mainly gets electronic waste from office gear, like laptops, computers, printers, or phones.
We have Fortune 500 companies like HP and Lexmark, insurance companies, banks.
The rest of its clients are secret, but Ingrid can tell us what happens to these devices once they get here.
Reuse, repurpose, re-engineer if we can't reuse it. Very last resort is recycling. What you see here is where we first get the material in. It's a FIFO type of process, first in, first out. That's how we work it. Here she's offloading a truck, so she'll go in, get her forks into the pallet and pull it out. This must have come from an office refresh. It looks like there's some old DVD players, some old stereo equipment.
The first stop, the scale.
Then they will get the weight and input it into our data center. And that's what Drew is doing over there with the computer. Then it gets tagged with a barcode. It'll tell us whether we go to destroy, recycle, or we go to reuse.
The building's broken up into recycling on the right and reuse on the left. We'll start here.
If we can reuse it and reuse the parts, then you're not making a new part. So this is the part harvesting area for laptops. Sometimes when you can't sell a whole laptop, we can remove parts from it and either rebuild a laptop to sell or sell the parts.
To get all these tiny pieces out of a device without hurting them, it takes a lot of skill and
different screws, a lot of different screws.
So much of it still needs to be done manually and to do it properly, and that's very labor intensive.
Memory units, processors, screens, keyboards, and motherboards can all be reused. Workers will clean them, check that they're functioning, and send them back into inventory to be sold again.
Lots of times when we're allowed to sell units, we'll do revenue share with it. So we'll share revenue with the client. So that's kind of a nice way to add life to the electronics and then also get some revenue back.
Big hard drives pulled from computers or servers are another moneymaker, but they come with an added challenge of security.
You can see the fence up. You need a key card to get in. I don't know if I have access. Oh, I do. So here is where you'll see the higher value material.
Any stored data has to be wiped before a drive can be resold.
We have a lot of banks and insurance companies as our clients, so you can well imagine that those folks want their data erased properly. This is where you'll see some of the wiping going on of the hard drives. At the end here, these have already been done, so they're ready to go to the next step to get resold. So our drives will sell wholesale or on eBay. You can see these guys are deemed for eBay. So you'll see 1 terabyte, 500 gigabytes, all different size drives. These smaller drives, there just isn't any value in it anymore.
So if something's simply not worth Sims' time to refurbish, it's sent to be recycled.
On the other side is destroy, recycle. And over here, we have a lot of folks that are depackaging and also removing hazards.
This part's called demanufacturing.
So we'll remove hazards, batteries, and all that type of thing before it goes to be shredded. On this side,
there's a lot of hazardous materials in electronics, like mercury, cadmium, and lead. And if devices end up in landfills, that bad stuff could do major damage to groundwater and soil.
This is what we want to ensure does not go into the shredder, because this could be really dangerous for fire. If we leave toner in there, I mean, it goes up like nothing. Toner is explosive. And then the plastic acts as a fuel source. That's our biggest challenge.
Everything that's not hazardous gets shredded.
So this is Lori, and Lori is running the shredder, all with a mouse, right, Lori? This is the control room.
I have control of how much goes in the shredder, how much is on the belts. I can stop the belt, I can speed it up, I can jog it.
It's a 400 horsepower quad shredder, which means you have these teeth that are grinding up all the material here, and those are nice printers that are getting eaten up and ground out to this on the outside. And this is the really cool part. It's very noisy. The first thing that we're trying to do is remove any steel.
A giant magnet overhead pulls out all the steel.
This is where the charge is added to the material, and based on the plus and minus will repel. So the aluminum gets thrown the farthest away, so that's why aluminum is here. Then the circuit board is in the middle, and the plastic falls right down because it doesn't accept the charge.
The leftover mix heads to another machine named Heidi.
Heidi is German. Originally, we were using it to separate plastic, but the technology wasn't keeping up. It doesn't work on black plastic, and you see today, everything's black plastic.
Now, Heidi separates everything using infrared technology.
Ginger's our metal finder. She was named after the engineer who designed her because he had a ginger beard. And Ginger is just taking out any further metal that's still within the plastic mix.
What's left goes into the Dutch sink float machine, named Otto.
So I guess that's the only male machine we have.
In Otto, plastic floats, while everything else sinks.
We scoop off the top, the good stuff, and that's what will go to Montreal to our plastic compounder, and then goes back to HP to get reused into parts.
And those raw materials can make Sims some pretty good money.
So we really want to recover that value.
Every electronic has precious metals in it.
Some gold, some copper, some platinum, some palladium.
So all these elements can be separated and sold to be reused piecemeal. The copper and precious metal streams will go to a copper smelter in Canada or in Europe or Japan. The steel will go to a steel mill here in Tennessee.
But with more than 75% of e-waste landfill bound, companies are missing out on huge profits. To put it in perspective, in 2019, an estimated $57 billion worth of precious metals and valuables in electronics were thrown away or burned.
If we recycle it, then we're not digging holes and mining for virgin metals. It's a way to get some really precious commodities without expending all that energy and damage to the environment.
But it's a catch-22. Recycling e-waste could be a moneymaker, and it's better for the environment. But it's both really hard and expensive to do.
They're not designed to be recycled. Many different chemical compounds all smashed together. When devices got smaller and smaller, removing whole components became less and less possible.
Treating and disposing of these hazardous materials is dangerous and pricey. Recyclers also have to constantly upgrade machines and processes to keep up with this changing technology. And that's costly too.
We normally change the blades once a year, and when it gets towards the end, the blades get a bit dull. That's when we get a little bit anxious, and sometimes they're jams.
Sims has invested 1,000 hours updating just its Sally the Shredder machine. And while recyclers are facing all of these challenges, e-waste is only expected to increase by 38% over the next decade. So is there a way to make e-recycling easier? Some say it starts with manufacturers.
What a lot of the manufacturers are focused on, rather than making products live a long time, they see their way out is to keep selling as many products as they can as rapidly as possible. And they try to compensate by saying, don't worry, it's recyclable. And so this churn and burn mentality is very harmful.
Jim thinks one solution could be for manufacturers to create electronics that are actually meant to be recycled. For example, making devices that don't have toxins, so they're safer and easier to break down. But until that happens, Sims will keep wiping and shredding those hard-to-recycle electronics.